Hi, I'm Adrito and I'm currently doing a PhD in artificial intelligence for neurosurgery, but my original undergraduate degree was in mathematics from the University of Cambridge. It's been almost 10 years since I took my A-levels now. I took them in 2012, and for a bit of a laugh, I thought I would retake them, this time the 2019 paper, to see whether I'd lost any of that mathematical ability. In my original A-levels, I got A stars in maths and further maths, and even did some extra modules in further additional maths, so hopefully I can still do some of the basic stuff. So obviously I've not seen these questions before, so I'll be going in this blind, and of course I will try and explain my answers as I go along like a good student. And yeah, let's start the timer now. I think I've got 2 hours to do this. It's like the new version of A-levels without AS levels. So yeah, let's start that timer and begin. So question 1. I'm obviously reading off my laptop because I don't want to just print paper for the sake of it. So we have f of x equals 3x cubed plus 2ax squared minus 4x plus 5a. And we've got x plus 3 is a factor of f of x. Find the value of the constant a. So x plus 3 is a factor, implies that f of minus 3 equals 0, because obviously if you plug in minus 3 you get this to be 0, so then the f of x, which is x plus 3, is a factor, so x plus 3 is obviously factorized, so you get f of minus 3 equals 0, so that implies that 3 minus 3 cubed plus 2a minus 3 squared minus 4 minus 3 plus 5a equals 0. So 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, but then the negative sign. The negative sign doesn't matter here, so we've got plus 18a. And then these negative signs cancel out, so plus 12 plus 5a equals 0. So we can just shift this, so it's 23a equals 81 minus 12, which is 69. I think this is a calculator paper, but I actually don't own a calculator, but we can figure that out when it comes down to it. I'll probably just use Wolfram Alpha or something and just not cheat on what I'm using. So yeah, we get a equals 3, so fairly simple 3 mark starter. Okay, question 2. Figure 1 shows a plot y equals x cos x measured in radians. Show using the diagram why the equation has only one real root. So effectively they've got cos x minus 2x minus a half equals 0, so that implies that cos x equals 2x plus a half, because they've got the cos x graph. Looking at it, it looks like it's like a 1 by 1, so 1 square is equal to 1 value, 1, because it goes through pi at just past 3 and then 2 pi at just after 6. So given it only has one real root, well, I mean, I don't have the actual diagram, so let's do a sketch here of what I would draw. So we've got pi, 2 pi, minus 2 pi, 1, minus 1. So cos looks something like this. And this graph 2x plus a half, so it goes through a half here, and then the gradient is 2x, so it doesn't matter too much. It's something like this. So this is, say, y equals 2x plus 1, and then let's call this z equals 2x plus 1, and call this y equals cos x. So z equals y implies that cos x, written the other way around, 2x plus 1 equals cos x, and this has only one intercept. Just like one intercept, and therefore it's only got one solution. And cos doesn't do anything stupid like wrap around itself or anything like that. And so that would be my reason. I don't know how much more you need to write for that, given it's 2 marks, but I think this is probably enough. And given that the root of the equation is small, use a small angle approximation for cos x to estimate the value of alpha to 3 decimal places. So cos x, small approximation. I assume they only want us to go cubic, because quartic, because, no, what am I talking about? square. They only want us to square value because otherwise it would just be ridiculous, I think. So 1 minus x squared over 2, and then it would be x squared plus 4, but we just call this like some negligible terms. And yeah, we just plug this in, right? So 1 minus x squared over 2 minus 2x minus a half equals 0. And that means that a half minus x squared over 2 minus 2x equals 0, which implies, so let's just times this everything by 2, then times everything by minus 1, so x squared plus 4x minus 1 equals 0. Does this factorize? Oh, I made any mistakes. It should factorize, right? These sort of like questions generally factorize. Minus 2x minus a half times everything by 2. I don't think I've made a mistake, so let's just complete the square because I can't be bothered to. I don't even remember what the quadratic formula is off the top of my head, to be honest. So 1 plus x squared plus 4x plus 4, so we need to take a minus 4 off, minus 1 equals 0, so squared, so x plus 2 squared equals 5, which is x equals minus 2 plus or minus the square root of 5. And because we only want one intercept, because there's no like secondary intercept, so we need to take the positive solution of this. So x equals minus 2 plus the square root of 5 as x greater than 0. Let's just argue that, and that would be my final answer. Okay, they want it as an actual decimal, and this kind of makes sense as well because root 5 is just bigger than 2, and so so we have a number that's quite small. Yeah, I mean, I can plug that into a calculator and get it to 3 decimal places. I'll leave that as an exercise for the reader. Yeah, I hate when my professors used to say that as well. Okay, so question 3. Here we go. We have y equals 5x squared plus 10x over x plus 1 squared, and x is not negative 1. Okay, show that dy by dx equals a over x plus 1 to the n for some constants. Presumably n is some integer. Okay, so we could probably use the quotient rule, which is just the glorified version of the product rule, but it looks like the top is actually 5x squared plus 10x can just be factorized out, right? So y equals, okay, let's just write y equals 5x squared plus 10x over x plus 1 squared, and then this can just be factorized out the x plus 1, right? So you take the 5x plus 1 squared, so here we get the 5x squared plus 10x from here because this becomes 2x times 5, so 10x, and then we've got an extra 1 plus 1, so that's plus 5, so we need to take that off, minus 5 over x plus 1 squared, and so that simplifies to 5 minus 5x plus 1 to the negative 2. And so this makes taking the derivative way easier because this just becomes constant. So the minus 2 comes to the front. So it becomes 10x plus 1 to the minus 3, or in the form that they want, 10 over x plus 1 cubed. So a is equal to 10 and n is equal to 3. Easy. Turn the one, that's 4 marks. I guess because if you use the quotient rule, it will take a long time. Okay, so deduce the values for dy by dx is less than 0, so that's simple. That's just 10 over x plus 1 cubed is less than 0. So the top is obviously always positive, so it's just when x plus 1 cubed is less than 0. And because we've got a cube, we can just write x plus 1, x plus 1, x plus 1 less than 0. And then, so this effectively means for any cubic, you know that it only has to be one of those terms has to be less than 0 because the 2 other terms, I mean, I'll write it down explicitly, is less than 0, but this is a positive term, so it just implies that x plus 1 is less than 0, so x is less than minus 1. for dy by dx less than 0. Okay, so moving quickly, I'm about 10 minutes through and racking up the marks, I hope. So 4a. Find to the first 3 terms in the ascending power of x, the binomial expansion of, okay, let's just write this as 4 minus x to the minus a half. Let's take out the 4, so we've got 4 to the minus a half, 1 minus x to the minus a half. And so we know this is just easily just half, right? 1 minus x to the minus a half. And the binomial expansion goes 1 plus minus a half minus x. How many terms? First 3 terms. I'm just blind. Plus minus a half, and then this minus 3 over 2, minus x squared over 2, plus, and then the first 3 terms. So half, 1, and then this simplifies to a half x. And here the negatives cancel too in the same way they did here. And the negatives cancel here because it's a squared, so we have 3 over 8 x squared. And then, plus blah blah blah. And then, so the final answer is 1 plus a quarter x plus 3 over 16x squared. Easy. Okay, this expansion can be used to find an approximation for root 2. Possible values of x that could be substituted are x equals minus 14, 2 minus a half. Without evaluating, states given a reason which of the 3 values should not be used. So the binomial expansion is only valid for small values of x. So clearly, it's just, x equals minus 14 is too large. Okay, I guess they put a negative in to kind of use it because it's like magnitude rather than it's absolute rather than where it is on the real line. Okay, and then state given reason which of the values would lead to the most accurate. Well, just take the smallest value. So x equals minus half would give the best value as it is a smallest. Okay, my handwriting is awful, but you can, from what I'm saying, as it is the smallest. Okay, done. Let's put this to the side. Question 5. Okay, let's not move. That was my natural instinct to move it closer to me, but for the recording, which I will just double check is still going, looks good. Yeah, 13 minutes, easy time. Okay, we have f of x equals 2x squared plus 4x plus 9. Okay, write it in the form of ax plus b squared plus c. That's basically how you should write all of these stuff. So let's take the 2 out. So we have x squared plus 2 plus 9. And then they just want us to complete the square on this. So that's x plus 1. So x squared plus 2x plus... No, wait, what am I doing? 2x, yes, obviously. Getting ahead of myself because I clearly knew that's what it was. Okay, x squared plus 2x plus 1. So I need to take off 1 plus 9 equals 2 x plus 1 squared minus 2 plus 9, which is 2x plus 1 squared plus 7. So just to do it on the side as a check, x squared plus 2x plus 1 plus 7, so 2x squared plus 4x plus 2, oh my god, plus 2 plus 9, yeah, plus 9. Okay, that's the original. Okay, if I can't use something simple like that, what is going wrong? Okay, sketch the curve and showing any points of intersection and coordinates of any turning points. Okay, so we know that a turning point by default is -1, and so we know that -1, 7 is a turning point. But as a general rule, I remember just draw the sketches in the transformations, right? So we have, this is y equals x squared, and then that transforms to with a -1. So that's y equals, I mean, it doesn't really matter what the factor out front is, and then we just shift it up, right? So you know that -1, 7 is here, and then it will look something like that. And then intersect, well, we know from the expanded version that this is a 9, and intersection, coordinate axis, any points of any turning points. That should be it. F of x or y, whatever. Yeah. Okay, next part, Ci. Describe fully the transformation that maps the curve with equation y equals f of x onto the curve y equals g of x. Okay, I'm not really sure what is going on here. Transformation. Like, does it mean translation? I guess so, because there's no other. It's not like flipping or. Okay. Let's just get it into the form that we had initially. So we've got 2x squared minus 4x plus 4 plus 4x minus 3, which is 2x squared minus 8x plus 8 plus 4x minus 3, which is 2x squared minus 4x plus 5. And then, so that's quite similar to what we had before. So let's do the same thing again. Okay, let's not make a mistake and skip steps this time. So 2x minus... Oh my, why is my head doing? 2 x squared minus plus 5, which is 2 x minus 1 squared. So x squared minus 2x minus 1. So x squared minus 2x plus 1, so we need a minus 1 plus 5, which is 2x minus 1 squared minus 2 plus 5, which is 2x minus 1 squared minus 3 plus 3. Okay, so the gradient is identical, so there's no like, I don't even know what you call it, squeeze, expansion, whatever. It's just a translation. So here, if we just sketch this graph, again, we know it's going to be of the exact same form, but the point now is 1 minus 3, so 1 minus 3. And it will look, where does it pass the axis? At this point 5. So it looks something like that, probably less sharp of a gradient, but it's okay. And so yeah, it's just a very simple translation of f of x by vector it goes from -1 to 1 as turning point, so vectors 2, and then 7 to minus. It's plus 3. I mean, it doesn't actually make a difference. That would make sense why the gradient is less like this. But they didn't ask us to sketch it, so it's not actually part of the question. Vector 3, and so this is 3 should be. So 3 minus 4. Okay. Getting a bit muddled up there with my very, very basic algebra. Okay. Part 2. Find the range of the function h of x, which is equal to 21 over 2x squared plus 4x plus 9. Well, we already factorized it because this is just f of x, right? So it is 21 over, what did I factorize it to? 2x plus 1 squared plus 7. And x is real, so you don't need to care about imaginary stuff. So yeah, when x is infinity, then this term just goes to 0, so h of x tends to 0, and then the same with minus infinity. Tends to 0, so we know that it's at least some 0th term, so it's always positive because x plus 1 squared is always positive, and obviously 21 over 7 is always positive, and so the max value is when this hits its minimum value, which is when x equals 0, minus 1 at the turning point, as we established. Here, the minimum value is minus 1, 7. So the minimum value, so when x equals, so let's say max h of x is when f of x is at min. Sorry, my camera just came up with some alert. Overheating, but that's okay. And then my handwriting is also atrocious, but that implies that h of minus 1, which is equal to 21 over 7, which is equal to 3, is h of x max. So that means h of x is less than or equal to 3, and then strictly greater than 0, because we know that this sort of graph, so it's like x plus 1 squared, so 1 over x squared just looks like this, right? So it'll be something similar, but shifted, and yeah, I mean I can't actually, because it was capped at like 3, right? So it'll be like that, closer to that, but then anyway, doesn't matter, doesn't ask us, so I don't need to think about it. Okay, next question, 6a. Solve for 180. Why? I was gonna swear. Why is it in degrees and not radians? Didn't we like establish stuff in radians before as well in like the cos x question? Or maybe it never did. I don't know. Anyway, okay, I'm gonna write this and then just convert the answers into from radians to degrees. So we know that 180 degrees is equal to pi radians. So 1 degree is pi radians over 180. So just remember this as a translation factor. Solutions based on entirely graphical models are not acceptable. Fine. So 5 sine 2 theta equals 9 tan theta. So double angle formulas. Okay. Sine 2 theta is sine A plus sine B plus cos A cos B. Okay, so it's 2 sine theta cos theta. Okay, it has been many years since I've had to use the double angle formula. So yeah, and then tan is just defined as sine over cos. So let me see. So we've just got 10 cos theta dot sine theta equals 9 over cos theta dot sine theta, and then the sine theta is cancelled, but we have to remember that as a solution. And then, so the other solution is cos squared theta equals 9 over 10, or cos theta equals plus or minus the square root of 9 over 10, which is plus or minus 3 over root 5. And then we've got minus pi to pi. So theta equals 0. So I mean, sine theta equals 0 implies theta equals minus pi, 0, and pi, because of course sine looks something like this between pi and minus pi, or 180 degrees and minus 180 degrees. So yeah, you can just write 180 degrees, 0, 180 degrees. Yeah, fine. and I'm not sure how we get the domain of these theta. So theta equals r cos. I mean, cos is a even function, so it doesn't actually matter because it looks like this, right? Between minus pi and, that's supposed to be closer to here, but yeah, minus pi and pi. So let's redraw something like that. So it actually doesn't matter because it's an even function. But anyway, a bit of a tangent. So as in, basically you can get rid of the plus minus. So it's 3 over root 5. Because that will give you double solution. Anyway, well, the point is that I need to plug this into a calculator, and I don't know what that is, but it's the plus minus solutions of these, because you can get one on either side of the solution. Okay, so let's go to Wolfram Alpha, is what I'm saying, because I do not have a calculator. So r cos 3 over root 5. It's about 0.8. How accurate does it want it? I mean, it wants it in bloody degrees, so I mean, I'm just going to write this 0.5 radians, and that would be, so this is pi is about 3.14-ish, obviously, so we won't be able to say that's like here, and then so we'll also get a negative solution here, so it's plus minus, and yeah, I mean, you can times it by the factor pi over 180 to get it into degrees for their satisfaction, and then to one decimal place, but I am not going to do that. Is that right? Just double checking. So what it's saying is that cos is about 3 over root 5, so about 3/4. So yeah, so we expect it to intersect around here, as I've drawn in this very small diagram that you may or may not be able to see. And it'll give you two solutions. Yeah, cool. Easy. Okay, B. Deduce the smallest possible positive solution of the equation 5 sine 2x, okay, we've got bloody degrees again, equals 9 tan x minus 25 degrees. Okay, well, as we've established on my previous sheet, 1 degree is pi over 180 degrees, so let's just convert that into that first. 2x minus 50 over 180 pi equals 9 tan x minus 25 over 180 pi. And this is the same equation, right? It's just 2 theta equals 2x. Well, theta just equals x minus 25 over 180 pi. And so whatever solutions we had before can just be translated into here. So we've got x equals theta plus 25 over 180 pi. And before we had x equals minus pi 0, positive pi, plus minus 0.8-ish. And so that means that, okay, what have I done wrong here? So just thinking, theta equals x. Oh, I just didn't need to arrange this. So theta equals, well, these solutions minus 25 over 180 pi. Yeah, so minus pi minus 25 over, okay, let's take out the minus pi 1 plus that, straight just this, pi 1 minus 225 over 180, and 0.8 minus 25 over 180 pi, and minus 0.8 plus 20 minus 180 pi, and then they want positive, so obviously this is negative, this is negative, so this is negative, so let's just put less than 0, less than 0, less than 0. And so it's between the size of these, but this is pi minus small, but pi is obviously like 3, 0.14, so this is like 3 minus whatever 25 over 180 is, which is what, like 10, as in like 0.1, approximately 0.13, so this is pi 1 minus 0.14 approximately, so, but then it's times by like a massive 3 here, and then here instead we've got a 0.8 minus, I mean that's just going to be too small, right? That's just negative. 0.8 minus 25 over 180 times pi is just going to be way too small. No, apparently not. It completely gets factored out because the yeah, this is a positive number. Okay, I'm just dumb and I need a calculator. So this is about 0.36, so it's more positive than this, I would assume. Let's just double check and not take my mental arithmetic as a given. So yeah, as I expected. So this is about 2.7 and this is about 0.36. So even with the whatever factors you want to do, so that's so the smallest positive solution is, yeah, arc cos 3 over root 5 minus 25 over 180 pi. Okay. Got through it. We'll just check that my recording on my phone is still working and I'm still getting all of this. Yeah, looks good to me. And so we can continue. So now I am 33 minutes through. So got an hour and a half, and I think there's, okay, question 7. It's 13 questions. Okay, so but it should be getting harder. So I'm probably on track for what like a normal person would be doing. Okay, my camera just turned itself off because it was overheating, so let's hope that doesn't happen again. Yeah, I was just reading out question 7. So in a simple model, the value of v of a car depends on its age t in years. So v is a function of t, so we can just write v equals v of t. Given some values, when t equals 0, v equals 20,000. When t equals, t is given in years, so when t equals 1, v equals 116,000. Use an exponential model for car A. Why would they use A? It's such a stupid thing. Anyway, as a possible, so let's use, so v equals, let's just call it alpha e to the, I mean it would be negative, but it doesn't actually matter, so let's just put beta t, because it's like, what do you call it, exponential decay. And then, so by default, we know that, well, it means because this just becomes 0, so we know that alpha equals 20,000. And then for t equals 1, 20,000 e to the beta, because t equals 1. So, okay, I should probably write t equals 1, and then from t equals 0. Because yeah, I've stopped explaining and skipping steps. I shouldn't be doing that. So yeah, when t equals 0, obviously this becomes 0. So then v equals 20,000, and so alpha is automatically 20,000. And so it's 16 over 20 equals e to the beta, which implies, so this has, that's 8 over 10 or 4/5 equals e to the beta, which beta equals, I mean, I'm just going to use log as the natural log. You might know it as ln if you're an A-level student. but that is just what it is, and because this value is less than 1, it's a negative, so we can actually just write that as 5 over 4, which is what we expected. So we know that v equals 20,000 e to the minus log 5 over 4t. Okay, cool. 4 marks. I struggle more with the easier questions, or the one with the fewer values of marks. Anyway, the value of a car A is monitored over a 10-year period. Okay, so let's just rewrite what I had before. V equals 20,000 e to the minus log 4/5 t. Just make sure it's not within the same brackets. The value of a car A is monitored over a 10-year period. Its value after 10 years is 20,000. Okay, so what they're saying is that t equals 10. How close am I to 2,000? So t equals 10 implies v equals 20,000 e to the minus 10 log 4/5, and I have 5/4 because I put a negative outside. Did I correct that here? Yeah, okay, cool. So back to our trusty Wolfram alpha. So exp minus 10 times log of 5/4 times 20,000. Wolfram tells me this is about 2147. So if that were, so that's about 2,000. So we say reliable model. I don't ever remember them asking us whether a model was reliable or not. Maybe they did. They just didn't care. Okay, C. The following information is available for car B. It has the same value, and its value depreciates more slowly. So it's the same value when it's new, but depreciates more slowly, and how you'd adapt the equation so it'd be used to model the equation of car B. So it just means that this factor, so say decay factor is smaller. So for B, decay factor magnitude should be less than log 5 over 4. I mean, I don't even know what log 5 over 4 is, but log 5 over 4. So my camera ran out of battery, but we had basically finished with question 7 anyway. You just had to show the gradient was less than 0.2. So moving on to question 8. Got some graph, some equation, y equals x plus 2, x minus 4. And it's bounded by the negative axis, so that's actually x equals 0 and x equals, when this is 0 minus 2. Show that the exact area is this value. So, I mean, just integrate, right? So that's simply x, well, it's a polynomial, so you just expand it, right? So 2x minus 8, which is x, well, this should be x squared. So x cubed minus 2x squared minus 8x. And they're saying that the integral between minus 2 and 0 is this. So y dx. So minus 2, well, I should write x equals x cubed minus 2x squared minus 8x dx, which is x to the 4 over 4 minus 2x cubed over 3 minus 8x squared over 2 between 0 and minus 2. We could simplify this down to a quarter x to the 4 minus 2/3 x cubed minus 4x squared between 0 and minus 2. Obviously when this is 0, it's 0, so we could get massive negative sign around. A quarter minus 2 to the 4 minus 2/3 minus 2 to the cubed minus 4 minus 2 squared, and I'm sure if you evaluate this or put it into a calculator, it'll be 20/3. Anyway, I literally can't be bothered to type it in. Okay, the region R2, also shown in the shaded area, is bounded by the curve, the positive x-axis, and the line with the equation x equals b, where b is a positive constant. Given that the area of R1 is equal to the area of R2, verify that b satisfies this equation. Okay, so what they're saying is that the integral between 0 and b of y dx equals R1, so that's 20/3, but it's under the axis, so it will come as a negative, so it's equal to minus 20/3. And we've already done this integral, which was simplified here, but it's now between 0 and b, but now because it's 0, so we just need to put the b out. So it's a quarter b to the 4 minus 2/3 b cubed minus 4b squared equals, well, we can just put, well, plus 20/3 equals 0, and then just times this all by 12. So that's 3b to the 4 minus 12 will give me a 4, 8b cubed, 12, 24, 36, 48 b squared plus 80 equals 0. Kind of looks like what we've got. So this is equation 1, and since we've got to verify, you don't actually need to prove it. You can just expand this out. So we've been given equation 2 is this. And so this is just b squared plus 4b plus 4. 3b squared minus 20b plus 20 equals 0. And so we have 3b to the 4 minus 20b, well, not equals 0, what am I doing? It's just, that is what it is equal to. 3b to the 4 minus 20b cubed minus 20b squared plus 12b cubed minus 20b squared. It's nice that these cancel. Plus 80b plus 12b squared minus 80b. These cancel too. Plus 80. Okay, maybe these shouldn't cancel because this gives us this. This gives us this. This does not give us this, so it should be a negative here. This 80 is good. This cancellation is good. So I've made a mistake here, I think. Oh wow, 4 times 2 is 80. Okay, 80 plus 12 is 92 minus 20 does not get me to minus 48. Three b squared minus, no, this should be a 20. Oh, okay. B to the 4 minus 30b squared plus 20b squared plus 12 minus 80 is here. Wow, okay. And that should 32 minus 80 or 80 minus 32 is minus 48. Okay, yeah, we've got it. This is the minus 8b cubed and 3b to the 4. So therefore 1 equals 2, verified. Okay. Okay, I just need to improve my basic maths, like arithmetic, adding numbers up. The roots of the equation are blah blah blah. The value of b is therefore blah 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 because it's that intercepts the positive. Explain the significance of the larger value. So that's just saying if you integrate from 0 to the higher b, because this curve goes down, those will like start cancelling out, and so you're like so far out that you become positive again. So I mean, I'll just draw this graph. So it's saying that this is R1, and then it's saying that this value of 5.442 is such that let's just call this R3, R4, and so R5, which is equal to R3 plus R4, which is equal to R1, where R4 cancels out the negative of R3. And that's the significance. Okay. That question took way longer than I expected, but I'm still doing pretty good for time. I don't know my exact time now because of all these stoppages, but even if I take those stoppages into account, I'm still on like 50 minutes. Okay, question. I just missed out a question. Okay. Question 9. Given A, B, blah, 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 is greater than 0, so A greater than B. Okay, sorry, I have shifted my... Am I still in frame? Just about. Okay. Log A minus log B is equal to log A minus B. I mean, that's not true in general, but in this case, I'm going to show that. Okay, so you're just using standard log rules. Log AB equals log A minus B. So that's AB equals implies... and then they want to rearrange for A, so we can just put A, B minus 1 equals minus B, so A equals minus B over B minus 1, which is equal to B over 1 minus, wow, what have I done? Log AB equals minus B minus 1, why is it squared? Log AB minus A so I'm just trying to think in my head. Log AB equals log A minus B, so that means AB equals A minus B. So where's the B squared come from? Right, because this implies AB minus A equals minus B. Log A minus log B, which implies A, B minus 1 equals minus B, which implies A is equal to B over 1, B minus 1. It's only a 3-mark question, so I have no idea what I'm doing wrong. Oh my god. It's a minus, not a plus. Wow, okay. I'm just okay, log A over B equals A log A minus, back in frame, apologies, A minus B. So that implies A over B equals A minus B, which implies A equals AB minus B squared, which is really actually okay. Because A 1 minus B equals minus B squared, which implies A equals B squared over B minus 1, because B is greater than 0. Okay, cool. I mean, we didn't need the B greater than 0 part there, but yeah. B. Write down the full restriction of B, explaining the reason for this restriction. Well, we know that A is greater than 0, so that implies that B squared over B minus 1 is greater than 0, but obviously B squared is greater than 0, so B squared is greater than 0, so that implies that B minus 1 is greater than 0, which implies that B is greater than 1. That's the full restriction. Okay, that's like very similar to what we had before. Question 10. Prove that for all n in natural numbers, n squared is not divisible by 4. Okay, this we never did this in A level. I mean, I know how to prove it. It's just like the standard odd even. It's like how you prove like root 2 is irrational, but that is beyond what I learned at A levels at least. So maybe they made it a little more difficult. So what you say, you should put n is even, so n equals 2k, and that implies n squared plus 2 is equal to 4k squared plus 2, which is a number that is a multiple of 4 plus 2, so not divisible by 4. And then you say n is odd, so n equals 2k plus 1, which is 2k, so n squared plus 2 equals 2k plus 1 squared plus 2, which is to 4k squared plus 4k plus 1 plus 2, which is equal to 4k squared plus k plus 3, and therefore not divisible by 4 because of this extra 3 factor, and this has this extra 2 factor. But I would have not been able to do this at A level, so I mean, I assume it's actually on the syllabus now, which would make it more accessible. But yeah, that's actually like reasonably tricky. Given x is real, the value of 3x minus 28 is greater than or equal to the value of x minus 9. So 3x minus 28 is greater than x minus 9. Is this always true? Okay. Best for this stuff is always draw a diagram, especially when it's something like this. It's just quite easy to draw. So that's x minus 9. And then we've got some mod function at 28 over 3. 28 over 3 is just bigger than 9 because 27 over 3 equals 9. So this is greater than that. So it's like this because it's got a sharper gradient too. I mean, it should be even closer to 9 if this was to scale. So this is 3x minus 28. And so yeah, clearly between this value, it's just not true. This because yeah. So let's just say when x equals 28 over 3, 3x minus 28 equals 0, but x minus 9 is equal to 28 over 3 minus 27 over 3, which is equal to 1 over 3, which is greater than 0. Therefore, this statement is only sometimes true. Okay, moving on. Good time. I've got 3 more questions, so hopefully should be able to finish this soon. A competitor is running a 20-kilometer race. She runs each of the first kilometers at a steady pace of 6 kilometers, 6 minutes per kilometer. That's a reasonable pace. In order to estimate her finishing time, the time that she will take to complete each subsequent kilometer is modeled to be 5% greater. Okay, whatever. So it's basically saying that the time is 6 mins for, let's just say, some distance is between 1 and 4, and then it's 6 times 1.05 to, let's say, t, no, so d, because it's a distance thing, greater than or equal to 4, greater than equal to up to the first 4 kilometers. So from kilometer, so she's done her first and second and third and fourth, so from fourth onwards. So I should write this into from 0 to because it's like in discrete, right? So 0, 1, 2, 3, 4. So 0 less than equal to, and let's put less than 4 just so there's no overlap, even though they're, okay, maybe less than equal to, and then d minus 4 here, so it's from d, yeah, greater than equal to 4, so when it's at 4, it's 0. But just make sure when I do it, there's no overlap if it comes down to that. Show that her first run sorry, I just saw part B and it's basically already what I just did. Which is, yeah, a bit annoying, but whatever. Show that her first run to the first show her first run to the, this way I should read the question first. Okay, show her first run to the first kilometers estimated to be, okay, so the first 4 kilometers is just, first 4 kilometers is 6 minutes. So it's 24 mins. Kilometer 5 is, whatever that is, 6 times 1.05, and then kilometer 6 is 6 times 1.05 squared, and I'm not I'm not an idiot. I can work this out. Okay, fine. Put it into Wolfram Alpha. It's annoying because then you have to convert from minutes to seconds as well. Okay, so okay, oops, mispress. 6 times, well, I mean, that's just 6.3, so I can do that in my head, but 6.3 times 1.05 is 6.615, so let's add these up. Okay, my handwriting is getting much worse, but it is okay. So that's 36.915 mins. So that is equal to 36 mins, and then 915 times 60. And 55 secs, as I think that was what was given. Okay, cool. B. Show that her estimate. I mean, I don't know how you show that. That's like what the information they've given. And it's from R equals, it's from 4 because it's from 0, because when it's 5, yeah, okay, fine. I don't know how you show it. So 5 kilometers is 6 times, I'm just writing what I wrote before, 6 kilometers is 6, okay, mins, 1.05 squared mins, dot, I don't know, 20 kilometers is 6 times 1.05, so as you can see it's a -4, so it's 16 mins, therefore are between 20, camera overheated again, but I'm just going to finish this question and then switch to another battery. That seems to lower the temperature. So anyway, estimated total times in minutes that it will take to complete the race. So it's 24 minutes for the first minutes, and then it's the sum of R equals 5 to 20 of 6 times 1.05 R minus 4. We can just take the 6 out. That is a standard geometric series. So 6 times A, 1 minus R to the, oh, but it's tricky because it's 5, from 5 to, wait, what am I doing? Because it's 1.05, so it's, I need to shift this, yeah. Which is equal to 6, R equals 1 to 20 of 1.05. Just shifting it down, so to the R, right? First one will be what? 4.05. Yeah, okay. And then I need to take this off, so 16, which is equal to 6 times A, 1 minus R to the n, so in this case 16 over 1 minus R, and then can I be bothered to put this in to a calculator? Probably not, and then we have to remember that it's got the extra 24 mins too, and yeah, I mean I probably should put this in a calculator, but I literally cannot be bothered, so I'm not. I'll lose those marks had it been, but I'm sure I would have time to put it in and then convert the time, but it's just not interesting to put things to a calculator. Okay, question 12. F of x equals 10 e to the minus 0.25x sine x. Show that the x-coordinate of the turning point of the curve of the equation y equals x satisfies the equation y equals f of x satisfies the equation tan x equals 4. So we just differentiate this, okay? So f prime of x equals, I mean we don't care about the 10, so 1 over 10 x prime of x equals e to the minus a quarter x, let me just write this, a quarter, and then minus a quarter at the front, sine x, plus e to the minus a quarter cos x. And then obviously e to the minus a quarter is not 0, so that implies minus a quarter sine x equals cos x, which implies I've got minus cos differential. Yeah, so this is right. Okay, what am I doing? Why do I have a minus a quarter up front? That is correct. It implies sine x over cos x equals minus 4, which equals tan x equals minus 4. But that's just... Sorry, am I still in frame? Just about. I'm setting this to 0. Wow, I literally can't do maths. Okay, equals 0, which makes this equal to 4, which equals to 4. Okay. And then we have to assume that cos x can't be 0, blah, 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 but I don't think we're going to care about those specifics. So B. Why is that 4 marks and the other ones are so much harder anyway? Sketch the graph of h of x. I mean, that's literally the same equation, but they've just put a mod around it. Okay, fine. So it's just the same graph, but okay. So we've got, okay, let's actually write it out. H of x. I'm getting a bit lazy because I'm getting a bit bored. Minus 0. Minus a quarter t sine t. So it's on like decaying exponential, and then from sine we go up, and then instead of going back down, go back up, and should be touching, and then go touching, and then write this as 10 e to the minus a quarter t. Let's call this y, and then this is my h of x. And then showing long-term behavior, yeah, it's decaying. Okay, the function ht is used to model the height in meters of a ball above the ground. Using this model, find the maximum height of the ball between the first and the second bounds. So it's saying between the first and this, but then if we look at the original graph, so it's actually this point and then modded. So it's the second largest positive solution of tan x equals 4. So x equals arctan 4 plus minus pi, because we know that tan looks like this and it's repeating at pi. But then we look at positive solution, so we only care about the positive, so it's going to be arctan 4, I mean it's plus pi n, so but plus pi, because this will be the first solution, this will be the second solution. So arctan 4 is approximately 1.3 plus pi, which is approximately 4.47-ish. So f of x is equal to 10 e to the minus a quarter dot 4 point, I've been using t, but it's just, oh no, they switched to t anyway, 4.47 7 or arctan 4 plus pi sine of 4.47, and then again you plug this into a calculator. Okay, I'll just do it. It's just like so silly to have questions. Hopefully it won't overheat. So yeah, it's just silly to have questions that have it in. I can't be bothered now because I've had to put my new battery in. Okay, so explain why this model should not be used to predict the time. I mean, it's because it's silly because the time period is the same. Time period is the same. Okay. Hopefully this is one question. No, 2 more. Okay, let's get this done. I'm about, in real time, I'm an hour and a half through. In actual exam time, I'm far less, like an hour 10, maybe? Okay, anyway. Question 13. The curve has the equation y equals p minus 3x over 2x minus qx plus 3. With obviously x not being minus 3 or minus 2. Where p and q are constants, passes through the point 3, 12. Okay, 3 halves, sorry. And 2 vertical asymptotes at 2 and minus 3, obviously. Oh no, it's not obvious. Actually, it means that this is... Oh, okay, it says, explain why you deduce that as literally the question. Okay, 2x minus q equals 0 at x equals 2. That's weird that they give it to you as x not equals 2 rather than x not equals like q over 2. Because that would... because that would actually make sense. Anyway, point is that they basically give you the solution. So we've got 4 minus q equals 0, so q equals 4. Due to vertical asymptote. Okay. 2. Show that p equals 15. Well, I mean, they've given you a point, right? So y equals p minus 3x now over 2 minus x minus 2, because we know that is a 4x plus 3, and then it goes through 3 half. So we know that a half equals p minus 9 over 2. 3 minus 1. 3 minus 2 is 1. 3 plus 3 is 6. So these halves cancel. So, which implies 6 equals p minus 9, which implies p equals 15. Okay, easy. Question 4 shows the sketch of a curve C. The region R showed is in figure 4. This looks like another integration question. 3 and 8 marks. Wow, okay. Show the exact value is a ln 2 plus a ln 3. So I'm going to use natural log as well when I write. Okay, so we don't know the intercept. Of when, okay, so we need to find the intercept first. So that's when y equals 0, which implies 3x minus 15 equals 0, because we know p equals 6, which implies x equals 5. Okay, so what we're actually doing now is 3 to 5 of y dx, which is equal to 3 to 5 of 15 minus 3x over 2x minus 2x plus 3. Okay, so I remember this stuff. This is like partial fractions or whatever. So let's take the half out, and let's take out a 3 as well. So 3 over 2, so this becomes 5 minus x. Okay, so 5 minus x over x minus 2x plus 3 equals a over x minus 2 plus b over x plus 3, which is equal to a x plus 3 plus b x minus 2 over x minus 2 x plus 3. And so as a quick trick on this, you can obviously term the term that you can add the terms together, so you get ax, so you get a plus b equals -1, and then 3a minus 2b equals 5, and you can work it out what a and b constants are from there. But another trick is if you just plug it in, so you say when x equals 2, implies that this side equals 3, and then we know that the b just dies, so then we get a dot 2, 5, so that implies a equals 3/5. So it's like way faster, I think. Can't remember who taught me this, probably a teacher, but yeah, it's an efficient method. So -3, so we get 8 equals, so then again, this side dies, so minus 5b, so that's b equals -5/8. So -8/5, wow. So that implies that the integral y dx is now between, so we can take out a 5 actually as well, so we can get 3/10, 3 to the 5, 3 over x minus 2 minus 8 over x plus 3 dx. Does that look right? 3x plus 9, 3x plus 9 minus 8x plus 16, so you get minus 5x plus 25, and then you get the extra 5 factor that we had before. So let's take out the minus 5 minus x, yeah. So that's just to verify that I did the partial fractions correct. So that's 3/10, brackets 3 log x minus 2 minus 8 log x plus 3 between 5 and 3. So that's 3/10, 3 log 3 minus 8 log 8 minus 3 log 1, which is 0, plus 8 log 6. And this can be split. I don't want to go on another page. So 3/10, 2 times, so this is 2 cubed, so this actually goes to the front, so it's 24. So 3 log 3 minus 24 log 3, so log 2. And then this is just 8 log 2 plus 8 log 3 from the rules of logs, where you can add them up. So that's 3/10, 11 log 3 minus 16 log 2, and then so we have 33/10 log 3 minus 48/10 log 2, and so we know what the efficiencies are. Obviously, in a real exam, I wouldn't write it, sorry if I'm out of frame as well, there we go, this small, but yeah, you get the point. And that was 8 marks. I mean, I think that is fair enough. You have to find the intercept, you need to find the points, and then you need to do some like relatively like simple simplification, but at least it leaves it in exact form rather than these like stupid like decimal expansions or non-radian degrees. Anyway, the curve C in the Cartesian plane is x equals 4 sine 2y. It's weird that they have to specify Cartesian as if they're going to suddenly introduce you to polar coordinates in the middle of an exam. Okay, and then y pi/4. So it's just flipped. The curve passes to the origin. Find dy by dx. Okay, so the easiest way is just to do dx by dy equals 8 cos 2y. So dy by dx equals 1/8 cos 2y, and we're trying to evaluate this at the origin, so dy by dx at 0, 0 is equal to 1/8 cos 2 times 0, so that's just 0, so it's just 1/8. Okay, bi. Use the small angle approximation to find an equal linking x and y. Okay, so assuming they just want linear because it's only 2 marks. So small angle implies sine 2y is approximately 2y, which implies x equals to 8y, which implies y equals to 1 over 8x. And then explain the relationship between the answers to A and B. I mean, I could write it out. It's just like same gradient. So near the origin, the gradient is 1 over 8 linear approximation. I mean, I don't know what, I mean, you could differentiate it and get, that means literally how, like, the small angle approximation comes about is from the differentiation of these functions. So it's just a very circular argument. Anyway, C, show that for all points, x, y lying on C, dy by dx equals this. And this hopefully be the last question. Okay, good. 3 marks, bang it out. And we've already got dy by dx. So we've got dy by dx equals 1 over 8, 1 over cos 2y. But they want it in terms of x. But then we know that in general, cos squared theta plus sine squared theta equals 1. And we've got sine 2y here. So that implies that cos squared 2y equals 1 minus sine squared 2y, which is 1 minus, and then sine squared in terms of x is 1 over x over 4 squared, which is 1 minus x squared over 16. So implies cos 2y equals, 16 minus x squared square rooted over 4, which implies dy by dx equals 1 over 8 times 4 over 16 minus x squared. So this cancels, you get 2, so 1 over 2, 16 minus x squared. Is that the form they want? So A equals 2, B equals 16. Done. Yeah, so I quickly marked my paper and I think I got 100%. Like, maybe you could argue the examiner would take a few marks off here and there because I missed a few steps, but in terms of actual mathematical principles, and I'm sure in an actual exam I would go through all those steps more rigorously. And so yeah, I've still got it. I can still do A-level maths, and you would hope so, because otherwise they would take the PhD away from me. If I can't do some basic calculus here and there. Maybe I'll do the other paper, the pure 2 paper, and maybe I'll look into mechanical statistics, so that will be way harder, because that is a lot of just knowing stuff that I have not used in a very long time. At least with this stuff, it's just like basic algebra and calculus. But yeah, hope you enjoyed this video. If you did, I would appreciate a like and a subscription. If you want to see more of my life as a PhD student, would also be appreciated. But if you want to see more videos like this, comment below, and hopefully I'll see you in the near future.